Hello everyone. Today we are going to look at another problem, which is problem 11. It's called container with most water. Okay, let's read it through. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height I. Okay. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so let's see an example then. Sample, we have height of 1, 8, 6, 2, 5, 4, 8, 3, 7. Then if we here we see that we try to get the widest and tallest one. In here it's pretty obvious that 8 and 7 are two of the most tallest one here. So if we take the first 8 and the last 7, then we would have 8 times 7, which is 56. Oh no, so the water here would be, say, how many spaces are there? 1, 2, 3, 4, 5, 6, 7. So 7 times 7, which is 49. So the maximum amount of water. So let's call it area here. Area is 49. Okay. And then we have example 2, where the given height is 1, 1. And here it's pretty obvious that we can only get 1. Okay. I think I understand the problem here. So we are given a tower in which the tower height is given in the array height, and then we want to find out the volume of the water that it can store at maximum, and we need to pick two endpoints. I'd like to clarify whether the length n that there will be. Okay, so clarifying number 1, range of n. So here we are given the n is between 2 to 10 to the power of 5, and then are they always valid? Valid. Then it says it could be between 0 and 10 to the power of 4. Okay, I think I understand the problem. Let me think of some possible solutions. So, I think for the first example, what we can do is, let's say we have 186.254.83.7. So I'm trying to be greedy here. So I take the leftmost and rightmost, then try to see what is the maximum that I can store here. So if I just ignore the middle or the middle height, then this would just give me 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 1, which is just 8. Let's try to draw it down here. 1, 8, 6, 2, 5, 4, 8, 3, 7. So if we take 1 and 7, this would give us 8. Then we see that, so if we, let's say, move the left one to right, we would have 8 and 7. This would give us the maximum. However, if we move the right one to the left, it actually makes the size become smaller, because in here it becomes 7, which is so that we got a smaller volume. So we don't want to do that. Alright, I think this problem could use a greedy approach, meaning that if for either side we try to get the maximum volume possible, meaning that if the left is larger, then we move the right one. If the right one is larger, then we move the left one. Okay, so let's try that. In here we move 7 to 3. This gives us 6 times 3, which is 18. Or notice here that the area here would be equals min area equals min of height I, comma height of j times j minus I. Then here we move the right one to the left again, which gives us 40. Then when they are the same height, then we could, well, in this case we could move any of them, but let me think how we can solve this. So then we can explore through both of them here. So thinking of whether there is a better example that we can come up of here. Okay, anyway, let's go through all of them. So split. So here let's just move the forward one. But this gives us 12, and then it's obvious that it will give us a smaller as we go along. So how are we gonna solve this problem? Okay, so actually if we, no matter which direction we move, all of them will lead to a smaller volume, because it doesn't matter if in the middle there is a taller tower. We will still end up getting a smaller volume. So let's write down as a finding here. Finding 1. Finding 2. If we have 8, 8. Let's say we have 8, a range of towers between 8. Then there is A until Z. I'm not sure how many, but let's take it from here. And then this will return like let's say that this will give us 8 times 8 times n. But if we just move the right one, this will still give us 8 times n minus 1, which is also the case if we move the left one, right? So it doesn't matter, and we could just move both of them to the right. Okay, we might as well move both of them to the middle, and then we continue on until we check out at the point where the I and j meet. Okay. And then the second example, we have 0, 0, and then we have 1, 1. Then this gives us just 1. Let me think of, okay, I'm just thinking about the edge cases here. How about we have, let's see, let's say we have 0, 0. In this case, it would just gives us 0. Right? I think there are not much edge cases to think of it. Does this make sense to you? I'm pretty good about this. May I proceed to coding? Thank you. Let's proceed to coding. And here I'm gonna use two index, which is L and right, left and right. Then this would be 0 for n minus 1. Then I'm gonna do while left is less than right. Okay, so I need the area. Initialize to 0. Then I'm gonna write down the area for the current chosen tower. This would be maximum of area, and what is that? So just use our finding one here in the formula. So min of height I, comma height j, I think it's better to refactor them into different lines. So the height h is min of height I, comma height j. Or in this case, the better variable name is left and right. Okay, and then the distance is between right minus left, and then the area equals minimum of area, comma h times d. Then we're gonna check whether the left is height L is less than height R. If height L less than height R, then left move to the right, and if height of L is larger, height of right one is less than height of left, then right we move it to the left, else we move back. Okay, so I think this should work. Let's try to check. With the first example, we have 186254837. Here we will initially have 1 and 7, which is pretty small. Then we move it to the right. Then this would be get us 49. And then if we move on, the right one will move. Then this would give us 3 times 6, which is 18. Then again we move it to the right. 8 times 1, 2, 3, 4, 5, 40. Then we move to at the same time. This gives us 4 times 1, 2, 3, 12. Then 6 with 5, which is 5 times 2, 10. Then we have this, which is 2. Then both are at the same point, and then we return at this point. The function will, the while loop will return, we exit, and then we return the area. Okay, so I think this should work. Let's try to implement it. Left and right equals 0, comma 1 right minus 1. Then let's call it max C here. And left is less than right. Height equals minimum of height L, comma height of the right one. The distance would be right minus L. The area would be H times T. So the max C is max of max C. Let's increase that, let's call it MA. So MA equals max of MA and the area. Then we check whether the height L is less than height of the right side, and the left plus 1. And if height L height right is less than height of the left one, and the minus 1. Else we move both of them. Right equals left plus 1, right plus 1. And we return the mark, the maximum volume. Let's see if this works. We got runtime error. The return is upside. Okay, how about this? Yep, so we got correct answer. I think there is not much test case that we can think of. Oh, and I almost forget again. The complexity here will be ON. Right? So ON, we could not do any better because ON is the time to go through all the elements in the array. So it is a cost that we must spend. And then the space is simply O1 because we don't create any additional array here. So I think this should work. So let me try to submit it. Hopefully you got it correct. Okay, we got an accepted answer. Let's look at what other people do. Yep, this is exactly what I did. Also what I did. Also the same. So I think this is pretty much the methodology that we could use to solve this problem. So thank you everyone.